Okay, and welcome to factoring simple trinomials. Now, in example 1, we have x squared plus 8x plus 12. And how in the world are we going to factor something like this? Well, the first thing I want you to note is that these things are always in the form of ax squared plus bx plus c. And we can only do this, we can only factor simple trinomials with the method that I'm about to describe when a is equal to 1. So you'll notice here that there's a 1 coefficient. Okay. Alright, so what's going to be the trick? Well, we're going to see what two numbers add up to equal our b term, and we're going to see what two same numbers are multiplied to equal our c term. Okay? And I think it's best if we just try and do some practice. So here's how I would do this if I were you. I would always choose my c term, and what I would do is I would write out all the sets of factors. So for example, I know 12 can be 12 times 1, I know it can be 2 times 6, and I know it can be 3 times 4, in no particular order. So what would happen if I were to add up all these? Well, 12 plus 1 is 13. Remember, we're looking for it to add up to 8, okay? So let's see, 2 plus 6, 2 plus 6 would be 8, 3 plus 4 would equal 7. Well, wait a second. We said we want the two numbers that multiply to be 12 and add to be 8. So it turns out 2 and 6 are in fact our winners. So let's just really double check this. Let's say, what is 2 plus 6? Is that 8? Yup, that's our b term. What is 2 times 6? Well, that's 12. That's our c term. Okay, cool. So what does that really mean? You're like, Mr. Hastings, I get that, but how do I break it down? Well, we know that x squared is really x times x, and we know that 8 and 12 can be broken down into plus 2 and plus 6. So this is how you factor a trinomial, or should I say a simple trinomial. Okay, let's move on to our second example. Okay, here we have our second example, x squared plus 12x plus 36. Now what in the world are we going to do? The first thing we want to check and make sure that a is equal to 1. Well, this is a 1x, so boom, checked, and done. Okay, the second thing we want to do is we want to go ahead and label our b term, and let's go ahead and label our c term. So essentially, what are we saying here? We're saying that something plus something is going to have to add up to be our b term, which is 12, and something times something is going to have to add up to be our c term, or in this case 36. Okay, now how are we going to do this? Well, I would always have you take your c term, I would have you write it out and break it down into as many sets of factors as you can. So we got 1 times 36, that's a set of factors. Let's see, we've got 2 and 18, we've got 3 and 12, and let's see, what else do we have? Oh yeah, we got 6 and 6. And I'll just stop there. There's some other ones. You could do 4 and 9. You could do, I think those are it. I think the only one I missed was 4 and 9. But, I ran out of space, so sue me. Okay, so if we go ahead and now add all these factors, remember, we're looking for the pair of numbers that add up to be 12. So let's see, 1 plus 36 is 37. That doesn't work. 2 plus 18 is 20. That doesn't work. 3 plus 12 is 15. That doesn't work. And 6 plus 6 is in fact 12. Oh, wait a second, we've got our winner. It turns out that 6 plus 6 is equal to 12, and 6 times 6 is equal to 36. So how are we going to break it down? Well, we're going to say this. Remember, what two things multiply to be x squared? Well, duh. That's going to be x and x. And then we'll just write, hey, since that's a positive 6, we write plus 6. And since that's a positive 6, we write plus 6 as well. Okay, let's go see a less clean example. Okay, here we have example 3, and this is actually one of my favorite examples. Notice I'm missing my x. Okay, fixed. Alright, so let's go ahead and tackle this. Let's see. Do we have a 1 coefficient for our a term? Yeah, that's a 1, x squared, check. We are good. We can use our simple factoring method. Okay, let's go ahead and label our b term, and let's go ahead and label our c term. So what are we really saying? We're saying that something plus something will equal our b term, and something times something will equal our c term. and using the appropriate colors, two things will add up to be -9, and they will also add up to be -8. Let's see. Using this nice orange here. I'm sorry, they will multiply to be -8. Okay. Actually, guys, I'm going to be honest with y'all. This is impossible as it currently is. This is impossible. I need to make one slight little change here. Let's make this a positive 8. My apologies. That thing that we originally had wouldn't factor, and I don't want to reshoot this video, so we're switching on the fly. Here we go. So we are now factoring x squared minus 9x plus 8. And what's this going to look like when we factor it? Well, remember, we want to see, okay, what things multiply to be our c term, in this case, positive 8. Now, you'll notice that there's something interesting here. We actually have a -9. And so this makes things a little bit more complicated. Let's see how. Here's all my factors of 8. There's 1 and 8. There are 2 and 4. And that's really it. So let's say I go ahead and start adding these. What do I get? 1 plus 8 is positive 9. And 2 plus 4, let's see, 2 plus 4 is positive 6. And wait a second. We notice that our b term is a -9. And both of those are positive. So what that's going to tell us is we actually might have to start playing around with some negative numbers. Now remember, this is positive, so a positive times a positive is a positive, but so is a negative times a negative. Okay, so we can say -1 times -8 is positive 8, or -2 times -4 is also positive 8. And what happens when we add these? Well, -1 plus -8 is -9, and check it out, we have our winner. So what was the actual answer here? It was -1 and -8. We know that -1 plus -8 is -9, and -1 times -8 is positive 8. And so when we go to break it down, it's going to look like this. As always, we know that x times x gives us our x squared, and our two values are x minus 1 and x minus 8. So that is how you'd factor that. Now let's look at one more, and this will be by far the most difficult example. So pause, finish taking notes, and let's move on to the last one. Okay, by far this will be the most difficult example, and let's run through all of our checkpoints. Let's see, is this something that has an a value of 1? Yeah, there's a coefficient of 1 there, so we can use our simple factoring method. We see our b term is a positive 12. We see our c term is a -45. And let's go ahead and write up this template. And guys, I would always encourage you to write up this template as you're trying these problems initially until you really get the hang of it. So let's see, our b term we know is our positive 12, and our c term is -45. Okay, notice it's always our c term where we start this off. And let's just not worry about positives and negatives. Let's just find out what are all the different values that we could potentially have. Well, there's 1 and 45. There is 3 and 15. Oh, and you know what I also forgot? I forgot 5 and 9. Perfect. Now, here is where it gets super duper tricky. I want y'all to think about this. When you think of two things that multiply to be a negative, well, you have to understand that one of those values is positive and one of those values is negative. What does that mean? What does that mean for our addition? Well, it means essentially what we're using is some form of subtraction, okay? That's why this is one of the more complicated examples, because it has that. Y'all give me 1 second. I have to plug up my computer. Okay, so it means that ultimately we're actually thinking about this in terms of subtraction. So here's what I like to do. Regardless of the signs, I like to say, you know what, Mr. Hastings, what is the difference? Okay? What is the difference? Well, let's think about this. What is the difference from 1 to 45? Well, the difference there is 44. Well, check it out, guys. We are looking for a difference of 12. So it can't be 1 and 45. Okay, let's see. What is the difference? What is the difference of 3 and 15? Well, the difference there is 12. Wait a second. I think we have our numbers. Now the next question becomes which one is positive and which one is negative. And so I go back to my initial B term and I'll say this. There are more positives. And guys, if there's more positives, that means your bigger number is positive and your smaller number is negative. Now let's double check this. Let's just make sure. If I say negative 3 plus 15, is that positive 12? Check. And what about negative 3 times positive 15? Is that 45? I'm sorry, negative 45. Yeah, check. Alright, and so it turns out we have completely solved this problem. We know it will be x times x gives us that x squared. And of course, we're now going to write minus 3 plus 15. Alright guys, thanks for sticking around with me for this one, and I will catch you guys in our next video.